Students, as I have told you that three types of laws exist which help us to create a relationship between the angles and the sides of oblique triangles. The first is the sine law, the next comes the cosine law, and the third is projection rule. The derivation of these three laws are important in our syllabus, as sometimes it has been previously asked in the previous years in the question paper to derive these three laws as per the requirement. So, going ahead with laws one by one, first I come towards the sine law, which looks like this. This is the sine law. This is the sine law. A upon sine A means what you see is side A is opposite to angle A. Side A is opposite to angle A. Similarly, side B, AC, is opposite to angle B. So B is the side name given to the side which is opposite to the angle B, and C is the name given to the side which is opposite to angle C. So what does the sine law says? Sine law says that if you have an acute angle triangle, it is very clear that the triangle ABC out here is an acute angle triangle with three sides whose measurement are A, B, and C. The one thing which needs to be means really observed is that the side name is as it is compared to the angle name. Means if you see the angle A, the side opposite to angle A has been named as A. The side opposite to angle B has been named as B. The side opposite to angle C is named as C. You keep this thing in mind while deriving it. And here is the sine rule. A upon sine A is equals to B upon sine B is equals to C upon sine C. This is the sine rule. And what does sine rule says? It says that in any triangle ABC, the sides are proportional to the sines of the opposite angles. In any triangle ABC, the sides are proportional to the sine of the angles opposite to them. The sides are proportional to the sine of the angles opposite to them. A upon sine A. Sides proportional to the sine of the angle opposite to them. B upon sine B. Similarly, C upon sine C. This is sides are proportional to the sine of angle opposite to them. So this is what the sine law says. If you go through the book, there is a definition which says that in any triangle ABC, the sides are proportional to the sines of the opposite angles. Okay, and moreover, this law can even be written in this form. Means you can write this law as sine A upon A is equals to sine B upon B is equals to sine C upon C. It can also be written in this manner. Means I have nothing, I have just done the invertendo part on it. This was the basic ratio and I have just inverted the ratio. Means both these forms can act as the sine formula. You use this one or you use this one. It's your choice. It's completely your choice. Okay, so now I go ahead with the derivation part of it, how to derive this formula. Okay, so please see to it. You can observe a acute angle triangle out here with the sides as ABC and the angles as capital A, capital B, capital C. Now this is an oblique angle triangle, that is an acute angle triangle, and I am deriving the sine relationship for an acute angle triangle. For this, I have done a construction within this figure. I have drawn a perpendicular AD. I have drawn a perpendicular AD in triangle ABC, which is clearly visible to you. That is a perpendicular AD. It was not present earlier. I had drawn it with the help of construction. Okay, now I'll be deriving the formula of A upon sine A is equals to B upon sine B is equals to C upon sine C from this part, from this triangle out here. As you can clearly observe, that this figure is having two right angle triangles within it. One of them is ADB and the other right angle triangle is ADC. Okay, these two right angle triangles are visible to you. So what I request you is, first of all, take the triangle of ADB. First of all, take the triangle of ADB and calculate sine B through it. Next, in triangle ADC, calculate sine C through it. Means doing the same, I again repeat, what I am doing is first taking the triangle ADB, that is the right angle triangle, and taking sine B onto it. And next I am taking the right angle triangle ADC and taking sine C onto it. Okay, please observe this derivation. This is the triangle ABD in which sine B has been applied. Sine is opposite upon hypotenuse, hence AD upon C. That is cross multiplying, I get AD is equals to C sine B, named as equation number 1. Now taking triangle ADC. In triangle ADC, I have taken sine C, which is AD upon B. Opposite, sine C is opposite upon hypotenuse, which is AD upon B. Hence AD is equals to B sine C. Now from equation 1 and 2, both the LHS part are being equal to each other. C sine B is equal to AD, B sine C is equal to AD. So from equation 1 and 2, C sine B is equals to B sine C. Solving it, I get the formula sine B upon B is equals to sine C upon C. Now, how to get sine A upon A? Please see to it. Now, in the same triangle ABC, earlier I have drawn the perpendicular from A to D on side BC. Now you draw the perpendicular from B to side AC. You get two right angle triangles named as ABD and BDC. Okay, and now apply sine A and sine C onto it. Now apply sine A and sine C onto it. If you apply sine A and sine C, you will be getting a result as sine A upon A is equals to sine C upon C. You will be getting the result sine A upon A is equals to sine C upon C. Similarly, as you have done it out here, the same procedure gets applied to this part. Means I am doing the same procedure. Please see to it. Now you please see this part. Means this was the triangle which I had. I had drawn the construction from B to D and applied the sine trigonometric function on this right angle triangle and on this right angle triangle, and I got the result like this. And since now the relationship is clear to you, that sine A upon A is equals to sine C upon C is equals to sine B upon B. Is that clear? This is for an acute angle triangle that I have drawn the relationship for you. Similarly, a relationship can be drawn for an obtuse angle triangle. This was just an acute angle triangle which I have taken. I will be drawing the same relationship by the similar method, bilkul the same method on the obtuse angle triangle. Please see to it how to do the construction part on obtuse angle triangle. Okay, please see to it. This is an obtuse angle triangle I have. The angle C is an obtuse angle triangle. So in this I do the construction. Likewise, I draw a perpendicular like this. AD. AD is my perpendicular. Side opposite to angle A named as A. Side opposite to angle B. Side opposite to angle B named as B, and side opposite to angle C is named as C. AD is the height. AD is the height of the triangle, which was not present earlier. I had drawn this side AD as a construction part. The same thing goes with this also. You please see to it how the derivation takes place for an obtuse angle triangle for sine law. Now please see to it that first of all you would be taking triangle ADB. Is the triangle visible to you? Triangle ADB, the triangle ADB. And in this right angle triangle, you will be applying the trigonometric function as sine B. Sine B will be equal to opposite upon hypotenuse. That is, sine B will be equal to AD upon C. Sine B will be equal to AD upon C in triangle ABD. Is that clear? Sine B is equals to AD upon C in triangle ABD. Similarly, I take the triangle ADC. Triangle ADC. In triangle ADC, if this angle is C, this angle is pi minus C. This angle becomes out here. This is a linear pair being formed here. If this angle is C, this angle becomes 180 minus C. And in triangle ADC, sine of pi minus C is equals to AD upon B. Sine pi minus C is equals to AD upon B. And if I solve sine 180 minus theta, sine 180 minus theta is sine theta. So sine C is equals to AD upon B. Therefore, AD is equals to B sine C. AD is equals to C sine B. I get a result. Sine B upon B is equals to sine C upon C. Means in the similar manner, you can do the derivation for an obtuse angle triangle also and get the same results out of it. That is the sine law. The result remains the same. You apply it on an obtuse angle triangle, you applied it on an acute angle triangle, it doesn't make any difference. It doesn't make any difference. The main part is what you need to know, that there exists a relationship named as sine law for an acute angle triangle, for an obtuse angle triangle. What we need to remember is the law. A upon sine A is equals to B upon sine B is equals to C upon sine B. Conversely can be written as sine A upon A is equals to sine B upon B is equals to sine C upon C. It can also be written as in this manner. If I assume these things as equal to K, so A is equals to K sine A, B is equals to K sine B, and C is equals to K sine C. It can also be written in this format. If I assume these three ratios as equal to K, so A can be written as K sine A. If I assume these three ratios is equal to sine A is equals to AK, sine B is equals to BK, sine C is equals to CK. Okay, so is this part clear to all of you? This is the sine law of properties of the triangle. This is the first law which I have discussed with you all.